Hi all, welcome to today's class. Today's topic is laws of motion. So, you might have already heard of the term force. That is when you push or pull some object, you exert a force on that object. If you push a body, you exert a force away from yourself, and when you pull something, you exert a force towards yourself. And also, when you hold a heavy object in your hand, you exert a large force. And if you are holding something tight, something weight tight, you are exerting a small force. So forces are everywhere. We need to apply force to move a football, which is at rest. And if you want to throw a stone upward, we have to give it an upward push. Even the breeze are applying some forces so that the branches of the trees can move in the wind. Even a strong wind would be applying a more heavy force so that it can move a heavy object like the roof or the buildings, etc. A boat moves in a flowing river without anyone rowing it. Clearly, some external agency is needed to provide this force to a moving body from rest. And also, an external force is needed to stop this motion. So, for example, if a ball is rolling down an inclined plane, you have to apply a force against the direction of motion in order to stop that ball. Or if a car is moving, we need to apply a force to stop, or we need to brake that car in order to stop it from moving. So, motion is everywhere, and this course of motion is force. So in this lecture, we are going to see what is force and the laws of governing force in detail. So let's move on to the topic. A force is required to put a stationary body in motion or stop a body from moving. And some external agency is needed to provide this force. An external agency may or may not be in contact with the body. And what if a body is moving uniformly? That is, a car is moving with a constant velocity in the horizontal direction. And do we require an external force to keep that car from moving? The great thinker Aristotle said that, or he held the view that if a body is moving, something external is required to keep it moving. And according to his view, an arrow shot from a bow keeps flying since the air behind the arrow keeps pushing it. And this view was part of an elaborate framework of ideas developed by Aristotle on the motion of bodies in the universe. But now, most of these ideas proposed by Aristotle of motion are now known to be wrong, and we are not considering God's motion. Now, this was the motion proposed by Aristotle. He said that an external force is required to keep a body in motion. Imagine that, consider an example that a child is playing with a toy car on a floor. So we need to constantly drag this car over the floor to keep it from going. And if you release that car and stop dragging that car, this car would come to rest. So we have already experienced this at many places during this motion, that we need, in order to keep something moving, we need to push that. Now external forces seem to be needed to keep bodies in motion. Now just consider this example in detail. If these objects moving around the earth are left to themselves, all bodies eventually comes to rest. Consider the example of a moving car. It comes to rest because the external forces of friction of the car by the floor opposes its motion. So in order to counter this force, we have to apply an external force on the car in the direction of motion. When the car is in uniform motion, there is no net external force acting on it. The force by the child cancels the force of friction by the floor. And so, if there were no friction, the child would not be required to apply any force to keep the toy car in that motion. Now, the correct answer to this question was given by Galileo, and it laid the foundation of Newtonian mechanics. Now, Galileo studied the motion of an object over an inclined plane. We consider this object here. This A object, first object is moving in an inclined plane, and we can say that from the laws of motion, we can say that this acceleration of this movie would be increasing. And now consider this second object. This object is climbing up towards the inclined plane, and we can see that this velocity of this object would be slowing down, or this ball would be retarding. Now, Galileo concluded that an object moving on a frictionless horizontal plane must neither have acceleration nor retardation. So here we can say that if a plane is climbing downward, it is accelerating, and if it is climbing upward, this object is decelerating. So now imagine that it is moving in a straight line or a horizontal force. Imagine that this is a horizontal surface, and this object is moving in this horizontal surface. So this object on a frictionless horizontal plane must have no acceleration and no retardation. So that means it should be moving with a constant velocity. There is another experiment by Galileo, and which also leads to the same conclusion. Here we have a double inclined plane. Here we have two inclined planes, and a ball is released from one of the planes, and it rolls down and climbs up the other. If a plane is smooth, the final height of the ball is nearly the same as the initial height. But in ideal situation, when the friction is absent, the final height of the ball will be same as the initial height. And this experiment is again repeated by changing the slope. Here you can see that there is a slope of this second plane has been changed, and the experiment is repeated. The ball will still reach the same height, but by doing